Start streaming. Done. 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 Are we in fact? Laptops away.
Excuse me, I didn't know.
And we're good. Where's the? Oh, okay. With the person next to you, you're all in like groups of 2 or 3. We could work there, turn around. Decide whether each one of those is ionic and covalent and see if you can come up with some clues as to which one is each. I will give you like a minute. I want you to determine whether each one is ionic or covalent and why. And I'll do attendance. And then ask you. Alex. And Aria. Ariel. Charlie. Is Charlie back?
No, she's still.
Okay. Zal. Eric. No. Has abandoned the course. I need to delete him. Guy. Isaac. Isabel. Jessica. Katie. Kiona. Natsuho. See who? Sterling, you said, is away. Jaden. And Tyler. Yes. Excellent. Okay. Confer with the people next to you. I'm not going to start off by asking you which one is or isn't. I'm going to start off by asking you in your little group, what rule did you come up with to figure it out?
No, you're right.
3.
Well, like, I think everyone has a
And this would be a really good moment to take out your data booklet, which you would need for this task. Like you always get your data booklet. I am about to update your data booklet. So if any of you have any pictures of any kind that you would like on the front cover, send them to me. We need a new picture. So we can distinguish it from other data booklets. Okay, Jaden, one rule. How did you distinguish between ionic or covalent?
Whether or not metal.
Excellent. That can often work. So, is that a metal? Yes. So is this ionic?
Yes.
Yeah. So that works. Does this work 100% of the time? Can anybody think of an example where it doesn't work? I will leave that for a moment then. See if anybody comes. If you think of one, throw up your hand. Kiona, any other rules? And what does it mean if it's non-metal? Yeah. As long as you say only non-metal, it is often covalent. Good rule of thumb. Can anybody think of a compound that violates that rule? There is one that I know of. There's probably a couple more. So let's go and we got those rules. CO2, see who? Ionic or covalent? Where? Sorry? You just changed your mind, didn't you?
Yeah.
Why did you change your mind?
It's not metal.
That's yes. Guy, MgSO4. Ionic. How did you know? It has a metal. Anything else about this that tells you that it would be ionic? Because there's another rule here. Yep. Has a polyatomic. So a polyatomic is often a giveaway. that it is a nonmetal. Sorry, it is ionic. N2O4, Isaac, covalent, why? Because there's what? No metals. NH4Cl, Tyler,
Ionic,
ionic, why?
because there's only non-metals.
That would make it covalent by our current rules.
Oh, my bad. There's a metal.
Where?
Oh, no, there's not.
There's not. So you're right, by the way. It is ionic. But it's the one that I was thinking of when I said one of these breaks the rules. How do we know that this one is? Yeah. It's got a polyatomic. So that polyatomic is where the exception. Ammonium is all nonmetals, but ionic is ultimately a cation and an anion, which often gets to be a metal and a non-metal. Those work for like 90% of the time, so they're good clues. But you could also get a polyatomic and then you get that polyatomic with a metal or a non-metal. There are some exceptions. H2O, Jessica, covalent, which we would call dihydrogen monoxide. Anything else in there? Oh, covalent. So covalent is all non-metals. You don't have any metals and no polyatomics either, actually. I'm going to add that in there. The type of naming we're about to do with covalence only applies to this very subset of covalents. They're for binary molecules, specifically ones that look like two types of elements, hence binary. As soon as you get into something like C6H12O6, what's that called? Glucose, it's sugar. And it has a whole different naming system. Organic chemistry especially has an entirely deep, rich, and complex naming system that we are not going to cover. I have covered it in class a little bit with people who wanted to know, and you will see it in probably Chem 11. But to show you how to do it, I usually start off by saying you already know how to do it. You just, in many cases, don't know that you know. So CO2, what is the name of that? Louder.
Carbon dioxide.
Carbon dioxide. We all know that. It would be hard to get through the daily news and anything on climate change without knowing a little bit about carbon dioxide. So, Natsuho, given that this is carbon dioxide, what is this? Louder. Carbon. You changed your voice, Natsuho. We'll try that again. Natsuho, what would this one be?
Wait, carbon.
So yeah, what would 4 be?
Quasi-centric.
Ooh, that's a really good guess. That's Greek instead of Latin. So they could have gone that way. They didn't. It's tetroxide. What helps me remember it is I used to be a big fan of Tetris, and Tetris comes from the same root, and Tetris is all the shapes you can make with 4 blocks. It's based on 4. And so that's why it's called Tetris. It's literally named 4, I think, in Russian. I don't know any Russian, but that's just my guess. That would make CO5. Arya? Oh. The hint is there's a shape that uses the same prefix that math teachers do their rituals in. Pentoxide, yeah, in a pentagram. And so then it follows the normal pentoxide, other things. Now this one we also know that's a common gas that you will have detectors for in your house. Isabel. Carbon monoxide. And for all of these, I've been dropping a letter because we happen to be using oxygen because we started off with carbon dioxide, but we wouldn't say carbon monoxide. And this is an English rule, is when you have an O and an E, or an A and an O, you drop one letter. And so it's carbon monoxide. You only do that with the oxide. If this was like a nitride, you'd go mononitride or tetraoxide. I'll write that up there so we know. Tetraoxide. And then because tetraoxide is hard to say in English, we actually drop the A. But for everything else, we keep it. So it'd be tetranitride, tetrafluoride. We would keep the A for all of these. We never drop the I. And again, they're English rules. These aren't science rules, so blame the English teachers. C2O would then be Katie. Let's go back here. If this is carbon dioxide, CO2, what would C2O be? Nice. Notice, up until this point, I have not been saying monocarbon. The first element, we just don't put mono on, even if it requires it, we don't put it on. It's just standard tradition, we just don't. So if you don't see a prefix there, it's because it's mono. Then I'm going to change up the elements finally because we started off with carbon dioxide. Alex, C2S2. Dicarbon disulfide. Excellent. So this is a naming system you probably could have guessed just based on carbon dioxide alone. So knowing that, take a minute, and I would like you to attempt all of these. Oh, before you do that, let's go through the prefixes, because that would help. What is one? Mono. And what is two? Di, because you ride your bicycle around town. And three? Tri, because you do ride your tricycle around town. Four? Tetra. Five? Penta. Six? Hexa. Someone casts a hex on you, coming from the number of the beast, 666. Which, interestingly enough, most modern translations, based on the oldest, most reliable research, shows that it's not 666. It might actually be 616. Sorry, biblical things probably don't really matter, but it's interesting that we may have gotten it wrong this whole time. 7, hepta. If you're in French, that should look familiar because of sept, and they come from the same root, it just evolved over time. 8, of course, for the octopus. Octa. The one I cannot think of an example for, and if you can find one, I'd like it. What is 9? Nona. Yeah, there's a gon for every one of those. There's tetragon, pentagon, hexagon, heptagon, octagon, nonagon. But you have to know what nona means to do it. Like we have octagons on stop signs, so it's easy. We have an octopus. Where do we have a nona, meaning 9 in the English language, anywhere else? Do we know? If you find one, let me know. I haven't found one yet. 10, of course, is deca, like decade. 10 years. No, not decade. I said it, and then I just rubbed. Now, open up your data booklet. Now that you've carefully written them all down, can you find these on a page?
Yeah, page 4.
Page 4. I've given them to you. They're on your data booklet. So if you ever forget, you can quickly look it up. But if you had to look every single one up, that would take forever. So it is useful to have it memorized. Now, go back and name these. Now that you have the written reference. Then I will ask 6 random people again. Okay. Comes the end. Name, done, name. Did you do this in last year?
Yes.
Okay. Part of this is also establishing, because when we started ionic naming, at least a good chunk went monoditri right away. And I find the hard part is not knowing how to do it, but making sure you distinguish between ionic and covalent. And you only do it for one of them. Because then when we add it back into ionic, it is less confusing. With hydrates. When you're done that, do a quick check. Where did it go? The answers are given to you. Can you tell ionic from covalent? Yep.
How come we don't use like I for the first one?
It's just a rule. We didn't do it for ionic either. And so I tells you it's the second element.
Okay.
That's the only purpose for it. Carbide, sulfide. So it's just a rule. Like you capitalize the beginning of a sentence and put a period at the end. Redundancy. The first element should always come first, but if I said sulfide fluorine, then you know I mixed something up. And we not go into the miss a row at all. It was supposed to double-sided. Instead, it looks like number 10 went on to the next page. And so it stapled it, and I killed slightly more trees than I intended for such a silly thing. But then again, I will kill 1,000 trees if it will raise your mark by 0.5%. 1,000 trees. As you're working through that, I will ask people for their thoughts. Ariel, first one. Yep.
Tricarbon tetroxide.
And, oh, hold it, we've got 2 pens up here. I could just call out 5 names. Coming up, first come, first serve. So, next up, Isaac. No, come on up, do it. 2 pens. Zhao,
Yeah.
2 pens, pick one. Aria. Oh, who needs more points? Katie,
So I just do this one?
you can pick anyone you want. You're first up. You pick whatever you want. Oh no, use a pen. Just it keeps the grease off of there. Oh no, I just lost track. How many people do we have? 1, 2, there are 4. Oh, now you press.
Look what you've done.
There we go. 2 people can write at the same time. So I need 1 more, and that'll be. See who?
Handwriting correctly.
It likes you today.
Look at that handwriting. Holy.
What?
So crazy.
Why is it called
Myself. So where's the eraser?
Oh, you want to erase?
It's too late. I'll just exit out. Chlorine.
Oh, perfect. Okay, that works.
Oh, oopsies. Wait, guys, how do you rope this out?
Oh my god.
What?
I need to rope this out.
Oh, you're trying to write with swirls and everything. Oh, that works. Excellent. Oh, no, it's got little brackets, only a couple of spots. Okay. Tricarbon tetroxide, good. Chlorine, corrected. Hexafluoride, good, except there's one mistake in here, if you can identify it. Yeah, these are mixed up. So it's fluoride, which is an ingredient in the kitchen. But other than that, the naming part's right. Sulfur tetrafluoride, good. Diphosphorus, heptoxide, good. Dinitrogen tetroxide, good. Dihydrogen monoxide, an incredibly deadly chemical. Contact with a solid form causes skin damage. Exposure to the gaseous form causes extreme burns. It's found in most cancers and in acid rain. It's actually the primary ingredient in acid rain. Okay, named a formula. How many of you I saw many people working on. How many of you are done this? Not everybody. Is there only 4? There's only 4. Do those 4. I'll give you another minute. Jessica, Isabel. Those four. Whenever you're ready. Pardon?
This is so
Oh.
weird, right? Yeah. I'm not. Oh, oops. Oh.
Negative points. I'll just decide someone else. Katie. Well done. I'll make sure Isabel gets the next one. Oh, the one out of your name comes up.
I do that.
So you're left with carbon disulfide. Tetraphosphorus digoxide, that's good. Carbon tetrachloride is a fantastic compound. We used to have it in spray bottles at the University of Victoria on the lab bench, just like you have water out there, because it will dissolve fats and polar things like in the same way water dissolves like dirt and salt. If you spray it on some people's pants, it will dissolve their pants because polyester is an inorganic, like a plastic. It's like the equivalent of a fat, and so it would just dissolve it away. They took it away from us in my year because too many people were literally spraying it on each other's pants. It's also a class 1 carcinogen, which means it's in the class of materials that is the most cancer-causing material that we know of. Okay, so we can do that. There is 3 that you have to have, not 3, there's actually 9, but I'll get to the other ones in a minute. There are 3 that you have to have memorized. Methane is CH4. There is an entire naming convention for CH4, and then C2H6, and then C3H8, and then it goes up, methane, ethane, propane, like propane gas. Butane comes after that, C4. You don't have to know any of those, but you'll do it later on. You just have to know the first one, CH4 is methane. You should know that NH3 is ammonia. So it is an exception. It is not it's not nitrogen trihydride, it's ammonia. You'll notice on your polyatomic ion sheet, there's another compound, a polyatomic very similar to it with a very similar name. What is it? Ammonium. What's ammonium?
NH4.
NH4
Plus.
plus. I don't know if it helps you, but it helped me. This is a long name. Therefore, it has more hydrogens. So ammonia is for the one with less hydrogens. If that helps you, it helps you. Don't confuse the two. They are different ammoniums for the polyatomic ion. Ammonia is for the other one. And we don't call dihydrogen monoxide. Its technical name is in fact water. So H2O is water in all the forms. There's a variety of other ones. Some of those is like PH3 is phosphine. It's a special name. Those are only if they're gases. I include them all here in case you see them. We don't put monosulfide for whatever reason. They're there, but you don't have to have those memorized. The ones in bold, you do. The last one, I'm going to skip over the acid section for a moment. And I'm going to turn all the way to elemental gases, page 9, I think. Just to mention the magic 7. And that would be H2, N2, O2, F2, Cl2, Br2. I'm running out of room. And I2. And these are diatomic gases. If you look on your, there's 1, 2, 3, 4, 5, 6, 7. If you look on your periodic table, it is these gases. There are 7 of them, and they make the figure of a 7. I don't know if that helps you, because it's 7 because we include hydrogen in that. So those 7 have special names for their elemental gases. Does anybody know the special elemental name for H2? I think if I do the first one, you might be able to guess it. Louder. This is hydrogen. So what's N2? Nitrogen. And this may seem silly, but if you're reading an equation and it says sodium chloride reacts with hydrogen to da 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 da. Sodium chloride we know how to do, that's NaCl. But when you see hydrogen, it is not H. Verboten. It is H2, because that is how hydrogen exists on Earth. It is always in a pair. So there's 7 gases that are always in pairs. If they're not in a pair, it's unusual. We would call it monoatomic hydrogen or something silly, because it just never happens. They will find each other and they will join up. They have to hold hands. And so this is just to belabor that point, that if I refer to oxygen, I mean O2, I don't mean O. Iodine even exists that way as a solid. They're little dimers of I2. They're holding hands the whole time. So we refer to any of those as their element, we mean the 2. However, if I refer to copper, so I say I have some pure copper, what is the symbol of copper? Cu. Copper metals don't hold hands, that's just copper, solid. It should be salmon colored and shiny and all the things that copper looks like. So all the other elements are their individual atoms. Those ones, however, are always in pairs. One we don't do, but maybe some of you have. Does anybody know what sulfur does? It is always in rings of 8. It's just got to be different than all the other ones. So, yeah. If you know that, bonus. And then lastly, I mentioned I'm making a new data booklet. I am going to very quickly, not right now, not today, go over the naming rules for any particular acid. But there are 6 you just have to know. If you know the rules, you can generate them. But on a separate piece of paper, because I didn't put it up on the notes, these are the 6. Hydrochloric acid, nitric acid, carbonic acid, sulfuric acid, can be spelled with pH there, acetic acid, or phosphoric acid. The special one is acetic acid. It's also known as ethanoic. It's known by both commonly, and people will write it this way, where it's that hydrogen. Notice that all the other ones have their hydrogen first. These are all acids. However, for this one, the hydrogen is last because the biochemists insist on putting it there because that fits the structure. And the inorganic chemists insist on putting it there because that fits the pattern. And so you'll see both versions depending on which chemist you're talking to. So either of those formulas is correct. You could write that down on a separate piece of paper or somewhere on your document. There's probably room on a particular page. So I just wanted to give you that on covalent naming. We have a variety of pages on here. You should now be able to do up to the last page, number 5, which is covalent naming. I will also, if you don't have this, or you've lost it, or you want another one for practice, sorry, I'm now standing in everybody's way. I can give you another one. I will also hand out practice binary ionic compounds. It has answers in the back, so you can just go through and practice this specifically. And then you have on line, on Kia, or if you'd like, I can give you some practice with the polyatomic, so you can practice all your nomenclature. We have a cross grade next week on the 21st. We are going to be doing some more work before that on reactions and identifying reaction type. That's it. And then it's more of this. We're just writing out reactions using our naming conventions. So I want the rest of this class to be practice, going through, doing some worksheets, asking any questions you need.
That's great. Like, are we gonna have time to review what, like all the other stuff moving forward?
That's all of your notes. So you have the review sheet from the previous test, and then all the notes since then. I can make up another one for the next one, but you also have the answers for everything up here. There should be sufficient practice there. If there's something more that you want, let me know. I'll be posting more too. This one?
Yeah.
Katie, did you get to know this one? Or did you get done? And I knew I had to get more. So I'm going to hand out the practice. This is just what we did today, so you can solidify that in your memory. Once you have that down. 1, 2, 3.
Is the cross grade cumulative?
It's all, yes, it's everything. And that gives you a chance to, if you improved in an area, I can use that as most recent evidence to improve your grade in like a previous test or quiz. Oh, yes. Hello. This one. Almost. Oh yeah. When we did our last test, some of you had handed in some material, and I said, pick it up before you go, because I quickly looked at it. Sterling's not here. So, pick up your material. Pick it up. Pick it up. Jason. Oh, I found out why you don't have it. And the original. This would be helpful to see. Natsuho. I'll go through them. Isaac. Wait. Oh, yeah. There. Isabel. See who? Both of those. And I think the rest is block E. Except for
I haven't
Sterling.
heard about that.
Is there anybody in Sterling's universe? I don't know. No.
Oh yeah, I kind of.
No, add it in here.
Wait, is this our test? Wait, is that our?
Confusion? What?
Did I? I didn't get my versions back.
Did you hand it in?
I think so.
Because anything that were handed in were put on the side here.
Double check.
And I don't see yours in here. There is one that's just a piece of paper, but it doesn't have a name on it. You could if it was ionic, but not covalent, because in ionic, NaCl isn't. It's a crystal that repeats I'm trying to draw. And so then you get NaCl, NaCl, it just repeats forever. But something like H2O2, which is hydrogen peroxide, is HOOH. So it's literally just those and nothing else. But this one can, because it's not actually NaCl. It's Na10,042 and Cl10,042, and every crystal is different. So we just use the simplest ratio. So you can simplify when it's ionic because it's a ratio, but when it's covalent, it is actually a ratio. So that one, which one is it again? That's a covalent compound. So triiodine bromide is probably some variation of I, Br, 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 I. It's probably not literally that compound. So you can't see it. For the first one, ene. Pi is only on the second one. Yep. Right. What? No. Yeah. What? Why do you think it should be covalent? Yeah, it's a metal. Yeah. So it's ionic. That's okay. I mean, there's a couple in there that can be tricky. Because if you do a compound with silicon, you can do like calcium silicide, and that sort of implies, well, it's acting as a non-metal. But if you have like silicon fluoride, it's right on the semi-metals. It could be acting as a metal. It could be acting as a non-metal. But where's bismuth? Oh, it's way down here. It's close to there, but it's still firmly in the metals. Okay, I'll take this back to the acids we need to know.